Okay, so we've got one more example. So still working with the composition of functions. Some of you might be thinking, I get this. I already know what to do. Leave me alone. I did want to show you an example that is not, it doesn't involve two linear functions. So right now, we're working with a quadratic and with a square root. So I did want to give you one example that was not linear before I kind of cut you loose. So in this example, we've got f of x equals, in parentheses, x plus 6 squared. G of x is the square root of x. And then minus 6. Notice that minus 6 is not under the square root. Okay, so same deal here. We want to know, are these functions inverses? Is f of x the inverse of g of x? Is g of x the inverse of f of x? We're going to do that, again, by using the composition of functions. Okay, so f of g of x, or if we put g of x inside f of x, let's see what happens. Okay, so my f of x function, in parentheses, instead of the x, I'm going to put square root of x minus 6. I bring down that plus 6, and I'll square it. Okay? Minus 6 plus 6 is 0. Okay? So you could write square root of x plus 0 and then square that, but you guys know we don't need that 0. So in this case, I just have my square root of x squared. If you square a square root, okay, that's just x. So right now, it looks like these might be inverses. I ended up with just an x. Okay, so I took my g of x, my square root of x minus 6, and I inputted it for x. Okay, so here's my x, here's my g of x function, then I brought the rest down. These can be a little trickier because they're not linear. Okay, so we've done f of g of x. Let's go ahead and do g of f of x. So g of f of x. Okay, so square root. But instead of the square root of x, I'm going to put the square root of x plus 6 squared. Okay, so I just replaced my x with my f of x function, and then I need to bring down that minus 6. Okay, so similar deal here. We've got an x plus 6 squared. We're taking the square root of that. So that would just give us x plus 6. Every time you take the square root of a square, it's just going to be what's inside. Okay, so x plus 6 squared, the square root of that is simply x plus 6. I'll bring down my minus 6. Okay, 6 minus 6 is 0, which you know we don't need. So we end up with x, which is good. So when we did f of g of x, we simplified and we got just an x. When we did g of f of x, we simplified and we got just an x. Okay, so yes, in this example, f of x and g of x are inverse functions. Okay. So if you end up with just x's, you're good to go. They are inverses. If you don't end up with just x's, then no, they are not inverses. That's all you got to say is no, these are not inverse functions. Important thing to note here is when you're squaring a square root, so right here or over here, you know that that's just going to cancel out that square and the square root. That's the only reason I wanted you guys to see a quadratic and a square root, just so I could point that out. Okay.